You may
Top
have
of the
to
morning to you,
allow
ladies
me
and
to.
gentlemen. This is day 6 of this year's Industry Samurai Awards and Conference. It's a great pleasure to have you here, to welcome you on board. We have an awesome presentation today, and a company that is a leading company in its sector. Let me quickly introduce to you the topic of discussion, and then the company and the speakers who are going to share insights with us today. We have the topic, which is industrial metrology and quality assurance solutions in focus, a Zeiss presentation. Zeiss is an internationally leading technology enterprise operating in the fields of optics and optoelectronics. The eminent speakers, the sector experts that we have with us today for sharing their insights is Manoj K. Sundaram, Head Business Development, and Hemanth Kumar, who is the Head of Sales. Both are from Zeiss. Let me introduce Manoj to you first. KS Manoj heads the Products Group of Industrial Quality Solutions Division in India, supporting technical sales for varied applications. He has spent more than 2 decades in tending to various portfolios in Zeiss measurement world, comprising contact, optical, and X-ray techniques. His experience in this field speaks a lot about his knowledge and technical expertise in this domain. An electronics engineering major, he started his 2 decades of career with services of industrial metrology products. Based on the experience gained and technical know-how, he moved to sales and product management and spent time interacting with customers and product development teams. In Zeiss, he successfully leads the surface and form products, and later the success was repeated with optical technology. Years later, he now heads the product management and marketing for other products, also including business development into new verticals such as NEV, aerospace, medical, electronics, and additive manufacturing in Zeiss India. His passion for metrology as a technical subject and knowledge in the field of quality is reflected in his discussions with customers and as a speaker, as you've seen in the past on this forum as well, and as you shall see today. The other eminent speaker that we have with us today is Mr. Hemanth Kumar. He is the head of sales with more than 20 years of industry experience. He specializes in industrial X-ray product and working with Carl Zeiss India for the past 17 years. He is a mechanical engineer passed out from Bharatiyar University in the year 1998. He started his career in sales and marketing of metrology products and completed over 20 years of experience in the field of industrial metrology. He has a rich experience in offering solutions for quality control labs and has handled large project business for Zeiss with many automotive OEMs. He was on deputation for 1 year in Germany and has worked closely with Zeiss product development team for the X-ray product. I welcome both the gentlemen and I invite Manoj to start the presentation. Over to you, Manoj.
Thank you. Thank you, Anand. Thank you very much for giving us an opportunity and also conducting this renowned industry samurai conference and awards. I think you are doing. I've seen some of the presentations in the last year, and they were quite good. And that's why we choose to participate this year. And thank you for the opportunity.
Thanks, Manoj.
So you can straight away jump into the presentation. Let me share my screen.
Thanks, from my side also, Sharon, for the nice introduction.
Thanks so much, Hemanth.
Is my screen visible?
Yes, it is.
Okay.
It is, Manoj.
Okay, good. Yeah. So, listeners and gentlemen who have joined the webinar in various digital modes, my name is Manoj, and we will be discussing on the topic, which is industrial metrology, that is measurements as a science, and quality assurance thereon, and what are our solutions from Carl Zeiss in this field. So this will be our discussion forum. To start with, we like this number, number one. Everybody likes it rather. So we would like to be number one in what we do. that would be one of aspiration for any company. And Zeiss is, I mean, I would say from the Indian context also, we are considered a leader in the dimensional measurements and the quality techniques relating to, please understand, we are talking in relation to dimensional quality and metrology topics. So we claim that we do a very good job in the field, and we have been doing it for quite a few decades. So this is where we are. This is a very, a slide which kind of captures the attention, I would say. And as you see here, as you see the slide, everybody could take a different view from this. So I'm going to ask Hemanth as to what he when he looks, or Anand, I would like you to tell us what do you feel when you look at this slide? What is your?
Well, I see an eye, and I see a pretty lady's eye, if I may, and I see the reflection of the moon, of a moon rising over the horizon of what I believe is an ocean on planet Earth,
Right.
and 175 years as the caption of the image. Is that a fair description?
Right. Thanks. Thanks, Anand. Yeah, I think I never saw the moon. Yeah. So Hemanth, maybe you can explain from.
So, I mean, I would like to appreciate the imagination of Mr. Anand. To give you what the slide is all about. It's about Zeiss is now 175 years you have completed, and what is the contribution of Zeiss this last 175 years is we help the humanity to see beyond in the sense when we talk of measurement, always the measurement is in terms of few microns or nanometers on a large object. The object can be as small as 1 millimeter to 5 meters. So in that big object, we try to find a very small details. So that is where Zeiss helps the industry to understand what is the resolution, what is that we can see the minimum, and this is what Zeiss helps. So this is where all about from engineering, medical, and what we do in the microscopy. So this is what we summarize.
Thanks, Hemanth. Yeah. So the summary is we make things visible to enable people to take corrective action, to enable people to understand what's going behind. So that's what we do. We don't produce anything. We support our end customers to produce, to visualize and see things. Good. This slide is a summary of what we do as a company, a global company. And there are some nice statistics out here. We may explain one or two to enable the listeners to get an idea. One of very interesting topics is you can see that the sixth topic of investment or in the reinvestment in R&D as a percentage of revenue. So we invest about 13% of our turnover back into research and development. This is one of the reasons why, if you recollect the slide number 1, where we want to be number 1. So that is a goal which keeps driving us to invest in all the verticals and stay as a company relevant to the community for about 175 years. There are other topics out here. I think Hemanth can pick up a few and talk.
Yeah, so again, people must be wondering what is the three technical Oscars. So again, Zeiss does contribution in the Hollywood as well as Bollywood, which some of you might not be aware, that the lenses used to capture all the fine moments in the screen, what you see. I would say 80% of the Bollywood movies are still captured by Zeiss lens, and we already have got 3 Oscars. So this is something which the listeners may not know. So this, for me, it is something which I would like to share with the listeners.
That's
Good.
amazing.
And you can see the founders here, Mr. Carl Zeiss and Ernst Abbe. Mr. Carl Zeiss was a founder of our company. He made lenses, hand grinding and polishing them into small microscopes and tools 175 years back. Then, he realized that, lenses cannot be made just by the requirement without mathematics. So he partnered with our founding father, Dr. Ernst Abbe, who's very famous in the metrology world. If people who know metrology would know what is Abbe offset, the Abbe's principle. So the founding principle of measurements was from one of our co-founders. So that's how we are connected to metrology.
Manoj, what is this 80% of microchips worldwide made on Zeiss?
Right.
This should be interesting, right? Yeah.
Right. That is a nice question. And, this is one statistic which says how we are connected to our kith and kin, our kids, and, everybody who uses a mobile phone or any digital device. So all these devices require microchips. These chips are generally made in a company in Taiwan. And one of a key process in this chip making industry is what is called as lithography. And in lithography, you have to talk about a few nanometers of, you have the whole circuitry, billions of transistors have to be fed into a small chip which works in your mobile phone. So this is done by a company called ASML. And to ASML, the optics required to make these chips are provided by Zeiss. So, it's a cascading effect that we provide optics to ASML. ASML provides the machines to the Taiwanese company, and thereby we control about 80% of the chips which are manufactured. They have a technology from Zeiss. So we are kind of proud of it, Hemanth.
Manoj, I think Anand made a nice observation when you showed him the girl's eyes. He said he saw a moon out there, right, arising from the surface. So maybe the 50 Zeiss camera lenses were sent to space. It has got some relation because the first picture taken from moon is through a Zeiss lens. So Zeiss worked in that project in that moon mission, and the camera which was carried by Neil Armstrong had a Zeiss lens there. So that's how the first picture was taken from moon. So you're right in a way, Mr. Anand.
Amazing, Hemanth, amazing, Manoj. These are some really fantastic, fascinating details, and a lot of these I'm coming to know for the first time. But I was aware, being a short filmmaker on the side, a documentary filmmaker on the side of the importance of Zeiss in lenses. They are very rarely highly sought after in the industry. There's no doubt about that. And some of the movies that I remember where Zeiss got awards were The King's Speech, if I am not mistaken, and The Social Network, for instance. These were some of my favorite movies where I saw Zeiss in the credits. So amazing history, very rich heritage. I have one question. I have many questions, but the top of my mind is about the surgical procedures. Now, this is something very interesting that I need to know from you. Is that the 300,000 figure for surgical procedures? Could you elaborate on this a bit?
Yeah. So, from microscopes, we moved into the ophthalmology industry, that is the eye care industry mainly, or also into brain surgery and, cancer surgery and so on, particularly relating to breast cancer topics and so on. So we have different varieties of surgical microscopes with which you can use laser to work on the cancerous tumor. Most common is the ophthalmology topic. So you go to any ophthalmology institute in India or around the world, the ones with which the doctors do the surgery is basically a Zeiss microscope. It's called a surgical microscope. So there is various versions of it, which you will see around. And that's one of our biggest business in India.
Amazing.
Good. So moving on, as we mentioned, we have the semiconductor topic on the first vertical where we make semiconductor chips. We enable making semiconductor chips. Then the medical technology, which Anand asked a question Also into consumer markets, I think Anand mentioned that he has used Zeiss consumer lenses, and also you could come into our Bangalore office where you can get these lenses tuned to you. We both, me and Hemanth, and this discussion belongs to industrial quality and research. That's the vertical we represent. So industry and quality and also research. So these are the three topics. Yeah, Hemanth, would you like to comment on this?
Basically, industry quality and research is the division where we belong to, and we are again subsegmented into industry quality solutions, and then we have a research microscopy solution. So we belong to IQS, and here what we do in industry quality solution is the product what we handle. Basically, it belongs to contact and optical measurements. That's how we classify them. Computer tomography, which is basically an X-ray based. And we also have the, once we do the measurement, we do a complete analysis, and also we manage the complete data. So this is the product line which we handle from industry quality solutions. And from RMS, that is research microscopy solutions, we provide products like light microscopy, scanning microscopy, electron and ion microscopy, as well as X-ray microscopy. So these are the product lines which the other division handle. But we, from industry quality solutions, we have good connects with the industry. So some of the products like the light microscopes or the electron microscope, we also combine this product, and we sell as a complete package to the industry, right from CMM to the industrial microscopy solution. Is the product range is what we have. So Manoj, you can take this, yeah.
Yeah, as you see the verticals today, we do not want to go through everything. So Hemanth is X-ray specialist. So we would like to cover the solutions to make it more interesting for the readers or to the listeners on X-ray and the last column. So the last two columns will be what we will cover today, and look at what is the application in the industry. For other topics, we can always, have a different call with our listeners. Yeah, so this is our headquarters in Bangalore. As you could see here, we are not a sales service office. We have a variety of portfolio, and there are some interesting topics in the office. Hemanth, would you like to share what all we do in this office?
Yeah, of course, this office here, what you see is a building. We have couple of production facilities. One is for IQS, which here we manufacture CMM, and also we have a production facility for consumer lens. So all the shops, maybe in the market, you see a Zeiss, wherever in the optical shop you can see a Zeiss logo. So all the shops get their consumer lens from this particular production facility. So we supply to all India as well as to the global market. So the machines produced here from IQS, the CMM product, also is for domestic as well as to the almost we export to 23 countries, CMMs which we export from here. So this is the brief about the facility what we have in Bangalore. And of course, the headquarter function happens from Bangalore.
Okay, so just a global view before we jump in. A few more minutes, we'll jump into the subject. A global view is that we have more than 40,000 CMMs, for which we are quite famous around the world. And we have, as you can see, about 50 QECs. QECs are quality excellence centers. We have 3 of them in India, that is in Bangalore, in Pune, in Chennai, and in Coimbatore. The 5th one will be coming up in Delhi shortly, where customers can walk in and take services. Also, we have a good network of engineers, 300 service engineers to support the customers. Okay, jumping into the subject, we all know that we are at a crux of transformation, which has also been highlighted in the Samurai Awards discussions many a times in the past weeks. That we are moving slowly from being a auto component and auto OEM industry, moving into different areas like electronics, NEVs, that is a car. Then windmill industry is also growing quite a bit, and aerospace, medical, and so on. So a growing a country like us would have to have a good synergy among all these industries to lead forward. Moving on, we would like to now discuss in these new industries. We'll pick up a few industries, few applications, and see how our solutions are supporting the customers. I would like to qualify one statement here that we are mostly into dimensional metrology, that is measurement of dimensions, measurement of heights, measurement of distances. So that is our key profile as a company. Okay. Now, each of these industries have different problems. When you look at electronics industry, the requirement is high volume. So you know that whether it is USB sticks or mobile phones or chargers, they are all made at a huge volume catering to the growth. So you need to be really fast. You have to have a high-speed measurement technique to qualify the products. Also, there are complex micromechanical issues because when you insert a USB charging point, the charging connector has to really sit properly. There are micromechanics inside which make it happen, which make it reliable. So those topics have to be taken care of. And if you look at the other industries like the car industry, we have question of cell safety, retaining of energy in the battery, motor lightweighting, and charging topics. Any thoughts, Hemanth, from your side?
Yeah, absolutely. I think there are different challenges now. If you see on the left side, it is only we were doing measurement of metal samples after the machine is done. But on the right side, we talk about small details like the components from the electronics data. They want to see minute details. And there also at a very high speed, the measurement challenges are too much in the sense we all worked with metals, and now we move into electronics and lithium ions, how the lithium ion behaves, how does it move from anode to cathode, how much of energy it can provide. So these are the various challenges now the industry is facing, and we have also in the last 5 years come a long way in terms of identifying such challenges and providing solutions for such challenges. So that is what I think today we will discuss, right, Manoj?
Right.
Yeah.
Good.
Manoj, I have a question that was regarding the couple of images that you showed along with this image on the left. Yes. So what is that icon which is next to the windmill on the right side?
This one?
Yes, this one. Yes.
Okay.
It's like a trophy. Yes.
Okay. Yeah. Right. Yeah. Right. This is our marketing people imagine a little too much sometimes. So that's what you see here. So let me explain that. So what you see at the bottom looks like a mountain. Actually, it is a powder. And the powder gets formed into an impeller or a rotating element. So that's what you see there. So this is a new, upcoming manufacturing field called additive manufacturing. So this is again a complex field which is coming up because because when somebody wants to rapidly develop a concept, rapidly develop a component, it is easy to develop it in additive manufacturing. It is almost like cooking. I don't want to get into details, but it is an upcoming field, very much useful in aerospace. And also I am told that, when you are talking about cars which have personalization, then additive technology will be used very much. Also in the EV industry, when we are talking about few vehicles initially, let's say a startup wants to make a few vehicles, he will not go the standard process of mold making, casting, machining. He would rather do the whole process in an additive way. So additive manufactured cars are available running in a prototype and experimental stages. So very, very interesting field, Anand. So, and these are the challenges around that field, what we address, but we will not get into that subject today. Powder quality, porosity, part verification, metallurgical topics, and so on. Does that clarify, Anand?
Absolutely. Yes.
Okay, good.
Thank you.
Okay. So as we get into the subject, we must tell you that being a quality company, we look for trends. What would come up in the next 10 years, and then our R&D investments would go into different areas which would suit these trends. So this is an analysis which is done by a body called BDI, and they have rolled out a manufacturing metrology roadmap. As you can see here, the four terminologies on the last column: fast, accurate, safe, and flexible. Individually fast, if you look them separately, fast, yeah, everybody wanted fast measurements always, everybody wanted fast measurements. But now today the challenge is you want all of them together. You want the measurement to be fast, you want it to be accurate, you want it to be safe, and you want it to be flexible to adapt to different changes which come up in the industry. So about 8 to 10 parameters have been listed here. I think, Hemanth, we could discuss on one or two. Yeah.
Right. How does it, this increasing integration, reducing measuring time and automatic data processing, how this is connected to the fast manufacturing metrology, Manoj?
Right. Traditionally, as you know, Hemanth, metrology was a separate room. If you go into automotive company, there will be standards room or metrology room, which will be, say, about 200 meters away from the production area. So the production guy would walk in with a part every 1 hour or every 2 hours, depending on the process challenge, get the measurements done and go back, which would roughly take from the time the part is cut to the measurement result on the hands of the operator would be roughly about 1.5 to 2 hours. There are thermal issues around it, why there is a time delay. But today, we are talking of, particularly when you talk about high-speed measurements, we are talking of increasing integration with production. So when you have to integrate with production, then you need fast speed. So you have to measure, if not at the takt time, but at least at a high speed, higher speed measurement. So that is one topic of increasing integration with manufacturing area. Second is reducing the measuring time. You must see that there is a thermal balance between the manufacturing location and the metrology location so that you can avoid that much time. Then you can look at optical ways of measuring the part instead of going the traditional way of touch measurements or X-ray, which you will be talking about. So these are two topics, and automatic data processing is actually a growing topic. What happens is, finally, we would not like, the industry does not want the operator to take decisions whether the part is good or bad. We would like to have an approach where, there are artificial intelligence techniques, machine learning techniques, which will look at the component or study the data and give you a judgment whether the part is good, bad, and, guide the operator. So this is a upcoming area of work. So using these three techniques, we would like the measurement to be fast, and faster.
Yeah, like the measurement speed should match the production speed in a simple sense, right?
Right.
Super. Automatic data processing. I think this is the topic which I will be also covering in the X-ray machines, because it basically gives the software name called ADI, automatic defect recognition, where the machine itself will decide whether the part is good or bad. So yeah, this also will be covered in the X-ray topic.
Right. Just one point I may say before we move on is the last one, that is increasing information density. Mr. Anand, yes. Maybe if you have seen one of our equipments, the CMMs, what we generally see, they used to pick up 10 points in a minute. That was the kind of information density which used to be there. But today we have about 1 million points in a minute equipments can pick up. So like we say, data analytics, there is a lot of data analytics coming into metrology also. So that is what is the increasing information density point.
That was the second question I had.
Oh, is it?
So you answered that intuitively. Thank you for that. Okay. All right. The first question I had on this slide was about the second point, the accuracy part.
Right.
which says reducing measuring errors or uncertainty. So what is the industry experience, Manoj, in terms of the percentage of errors without using this solution, and how much this thing accuracy is improved by the solution?
Uh, Okay, I'll give a historical perspective. As you know, India became an auto component hub from 2002 onwards. We caught on to the casting, machining, forging topics and moved fast. So that was an era when Suzuki's and German companies, German and Korean and Japanese companies, they inculcated the quality concept. And if you have seen the industries, they will talk about 100 ppm, 10 ppm, and so on. So there was always a bias towards reducing the measuring errors and measuring errors and lowering the uncertainty in the industry. We came in. I mean, our business grew because we were one of the most. We don't believe in if we don't believe in trust. We want real good measurement results. Trust is good, but we want results. So that is our motto. Whenever we sell any machine, we don't say the machine will work well. We say the machine will work with a certain degree of uncertainty, which is God sent. So having said that, today the challenge is to make the machine accurate, at the same time keep it fast. So this is where we are coming to. So,
Thanks.
okay, so I think without we will now jump directly. So this is the slide what we are quite famous for, the equipments what we supply into the industry. Talk about any OEM, any tier 1, tier 2 in India, they have a plethora of these machines, and we will not talk about this. Talking about the new age industries, you will see that the electronics industry has a lot of micro issues starting from few nanometers and so on. We will discuss a little bit on this using the microscopy solutions. Also on the key topic which will change our paradigm shift in the industry, we will talk about a little bit on the battery, lightweighting, car body, and so on in the new energy vehicle. We can move on, Hemanth, or you have any?
Yes, I've quite a few questions on this slide, so we could address those later during the discussion.
Anand, do you have any question?
Yeah, I have many questions on this.
Oh yeah, okay.
They could, answering them could require some time. Maybe we could take these up during the following discussion.
Okay, perfect. So we should cover ground. So let us move on. Let me just quickly tell you that we have, as a measurement company, we have 4 methods of measurement: contact, touch and measure; see and measure; throw a structured light and measure. The third one is X-ray. X-ray the component and look at everything what is inside. So that is a topic we will discuss in detail today with Hemanth. As we can measure anything from a few hundred microns. If you have a issue, if you have a residue which is captured and you want to find out what is the residue, whether it is a metal or a polymer, or is there a issue with it, we could measure anything from a few hundred microns to about 5 meters for its dimensions and a little bit of chemistry. Okay. Now this is the most famous slide Hemanth is very familiar on. So Hemanth, please get on.
Yeah. Thanks, Manoj. So basically, on the X-ray product, we broadly classify the X-ray into 4 groups. On the top left side, you see a metrotome, and metrotome is basically a high precision metrology and inspection. So this metrotome machines basically sit into a lab. And here, the X-ray, we focus more on the resolution aspect. So in general, what we do with X-ray is you place a component inside the machine, and what you get as an output is you get a virtual image of the part. And in that virtual image, it's a representation of how the part looks inside in 3D space. So the part can have a porosity. If you want to see the porosity, you can measure those porosity, you can classify those porosity depending on the size. So this is what we do it on a X-ray machine. So one part is porosity, and in high precision metrology and inspection metrotome machine, what we do is we not only see the defect, we also do a measurement, just like how we do it on a CMM. So the advantage is whatever see from outside you can measure, and whatever you are not able to see from outside, inside also you can do a measurement. So that is a growing field, and this technology is required for all the emerging industries now, especially into the NEV or the aerospace or the electronic industries. There, these machines we sell in large numbers globally. So this high precision metrology, we call them as Metrotome. Metrotome is a fusion of metrology and tomography together. So this is on the left side. On the right side, you see high resolution analysis and inspection. We call them as X-ray microscopy, because in Metrotome, we can go to a resolution of, say, about 2.5 to 3 micron is the limit of visualization in Metrotome. Whereas on the right side, the X-ray microscope, we can go, for example, the synchrotron model, the last one you see, you can go up to a resolution of up to 50 micron. So which means if you are having for the NEV, if you want to analyze the battery, then inside the battery, without opening anything, inside the battery, you can see how the anode, cathode separators are placed, what are the gaps, and if there are any defects to a submicron resolution, you can visualize. So these are, we call them as a high precision metrology machines and high resolution machine on the both left and right side. Just below that, you can see
in a video now.
I will give one is both are lab machine, and the other machine, what you see on the in the bottom, Volumax and Bosolo machine. These are all the shop floor capability machines, which can be placed in shop floor for high speed inspection. Here, the resolution we talk of above 100 microns. So these are the broad classification what we have. Then I think we can move to the next video, Manoj.
Yeah. So just tell me if the video is on.
Yeah, this is the shop floor machine. This machine is we call it as at-line machine. It can be kept close to the shop floor, wherein the part, as soon as it is cast from the casting machine, it can be brought into this machine. And here you see, this is a detector, what you see on the screen, which is on the left side, and on the right side, this is the X-ray. So we have a table coming out, and on top of the table, you're going to load the sample. And once the parts are loaded, this is the complete, now you can see the X-rayed image of the part. So here it can show you some defect, and there are some analytical tools wherein you will be able to check whether the part is good or bad, and whether the defect inside is allowable or it is over the limit. Manoj, the video is stuck. Yeah, now it's moving. So these are certain analytical tools. Yeah, and now once the parts are inspected, it is done. So this is how normally it is done in the production floor. So the requirement of the industry now, because of EV, there are a lot of safety factors which are coming in, and more there are requirements for 100% inspection. So the machines what you saw in the video, these are all machines used for 100% inspection for some of the critical components.
Good. So that component, what was there, Hemanth? Looked like a motor
casing. Yeah, it's a motor casing, and the porosity in those casing is very important. And again, that goes to EV vehicle, and they look at this porosity very critically. And that's where we help our customers to identify defects in those parts. And there are already a lot of users of our machine in this particular application.
Right. So I may just also add the component what you saw was a motor stator. You may think that we have been making motors for many decades. What is the need to check a EV motor so stringently? So the point, as Hemanth was mentioning, is EV motors are now made of aluminum, not a iron casting or a typical motor what you would see. The reason why they move into aluminum is all the components in a car is a dead white except the passenger. The basic purpose is to transport the passenger, not the heavy structures. So the designer's mind is to a lightweighting. So the motor casing would be hollowed in at many places, keeping only the structure intact. So that is the reason when you hollow out, thin it out, you have a requirement to check and see the integrity and compare the integrity with a design model. So that's a basic purpose why a X-ray is being done. Good. So let me now shift to the 3D. That is what you saw is a two-dimensional X-ray, which is similar to what the doctor would see. And if you recollect, we mentioned about the operator judgment, and Hemanth showed you in the video, pointed out a certain tools. So, if you go to a doctor and he looks at the X-ray, it is basically the doctor's judgment to tell you how good or bad you are. What is the issue with your bone or issue? Here in an industry, we wouldn't like an operator to do that. We want automatic software recognition, AI recognition to do that function. So that is a part of the 2D X-ray tool what we have, that you could have automatic defect recognition in the anode, cathode, or in these kind of casting components. Okay. Hemanth, I'll move on to the 3D topic.
Yeah. Basically, both in 2D as well as in 3D, we have automatic defect recognition software. So which enables the operator to make the judgment faster. So these machines are kept in serial, and all the parts which comes in get measured, and automatically it moves onto the line. So this is completely can be integrated to an automated line as well. So this is how few industries are using this machine.
Good. So here is another video, and this is a different equipment. The previous video was a two-dimensional X-ray. Here, this is a three-dimensional X-ray. And do we have this equipment in India, Hemanth?
Of course, yes. In our Bangalore facility, we do have, as well as in Pune. We are having Metrotome and Volumax machine in both these facilities. And of course, we cater more than, until now, I think more than 1,000 customers, they have come, visited our tech center and taken measurement services from these machines. So the results for them is absolutely unbelievable, because all these days they could see only the features outside. Now they could see what is there inside the component, and the biggest advantage for them is the design to market time has reduced drastically because of this technology.
Good. So let me play this video and.
So this is, as I told you, the metrology machine. You can see the component is getting loaded. It is rotated inside the machine with a complete 360-degree rotation. Once it is done, we capture series of image. So this is at the end of the scanning is done, you get virtual image of this part. So that virtual image is actually the complete representation of the part, and that representation we term that in terms of accuracy, it is 4.5. The accuracy can vary between 2.5 to 4 micron depending on the size of the machine. So that's how closer we scan a component. It can be either a plastic part with a lot of other materials as well, or it can be a aluminum cylinder block or cylinder head application. So this is how you visualize the image. After the scanning is done, you can give different color coding for different material, and now you can do a virtual cut section, and you can see how it is placed inside, and if there are any gaps, you want to do any measurements, you will be able to do with absolute precision, because we guarantee the accuracy of the machine just like how we do it on a CMO. So
Good.
those
So,
virtual
yeah.
yeah. Yeah, Manoj?
No. I just thought of adding a point that if people would like to get their parts inspected, which are multi-material, multiple layers involved, and they would like to check the parts before you want to send it to your customer end, you're welcome to talk to us, and we could do this.
Yeah. This
We
is
will
what
show
we
you
do
some more
day.
examples around it.
Yeah. This is again one more example of inline machine, and these machines are used predominantly in the in aluminum cylinder block and cylinder head application, where generally the defect of these component comes out when you start doing the machining. By then, from the casting phase to the machining phase, you might have already spent a lot of money and energy on this component. At the end of the cycle only, you'll be able to realize whether the part is good or bad. But in this particular layout, what you see from the machine, the component is coming out of the casting machine, and then it goes inside an X-ray machine. It gets completely checked whether the part is good or bad, and is it qualifying for the next process. Then after the measurement is done, it goes to the machining center. So the advantage is only the good part goes to the next machining phase, and because of that, you save a lot of energy and time. This is the important factor for all the industries as of now, and Volumax helps this in a great extent to all the customers.
Yeah. So the names Metrotome and Volumax are names for the functions, but they are basically 3D X-ray systems, and they vary in the location of measurement, the resolution, and so on. This looks like an animation to the viewers, but actually, this is actually a reality. This is happening in many companies around the world for different applications.
I think Hyundai uses this technology, BMW uses technology, Nemak. Those are a few companies which are using this technology.
Just to give a consumer view to this, we have just scanned a phone, and you can look at how a phone would be seen as you scan it from the top. The phone is kept in a horizontal mode, and this is the X-ray report of a phone. You can look at the micromechanics, the SIM card slots, the camera, battery. You can look at the connectors in detail, the SIM card ejection systems, electronics around it. So if you have a failure, it is easy to inspect visually, and you can learn a lot of abstract data to see how things can be controlled. So CT is also a tool which is used for failure analysis.
Yeah.
I have a quick question before I miss out. We go past these slides. This is about the 3D X-ray solution. Now, my question is that with 3D, we have obviously an extra degree of freedom, as they say. Now, for manufacturers, it's switching from 2D to 3D solution would, at least in India, require a lot of capital expenditure, particularly for an SME player. Now, in what circumstances or for what needs should an SME business consider a 3D solution, and for what kind of solutions, for what requirements? What would the typical requirement for which we should invest in a 3D technology, X-ray technology, from an SME point of view?
See, from an SME point of view, I would say the business case has to fit in first point. See, finally, this is a quality tool, and cost has to really fit in the Excel sheet. So your question is valid. Where a SME could look at is how to use the tool, to get quickly to the end product. When SME starts developing a product, he spends about 6 months to 8 or 9 months before the first version of the product comes out, and he starts supplying samples to his customer to get an approval. So these tools can help you in shortening the development time from 6 to 8 months to probably 2.5 months. So that is what, and he can get a lot of insights into how is the process of manufacturing, whether he's having the right process, right tools, what are the problems which are coming up at the supplier end. So he gets a lot of visibility into the chain of events, what goes into his component. For a SME, I would request that we have to move a little macro to see SME should probably talk to the association which he belongs to and say that could the association invest in equipment which could be used by everybody in a group. A corporate company having 20 different plants should talk to their management to see could we have one machine at a central location where developments happening in all the 20 units can get benefited. So this will be my two topics. Otherwise, if you put this machine in Excel sheet, ROI is not going to work out so easily.
I think adding to that, Manoj, the whole purpose of talking about this quality excellence center across all India is basically to support those kind of customers, wherein at the initial phase, definitely at the project starting phase, the kind of investment what is required definitely will not be there. So in that scenario, they can always come to our tech center and take the measurement service to start with. This is not only applicable for SMEs, also the OEMs, they do like that. No, unless they see the real benefit of such machine, because it's not 1 or 2 lakhs worth of machine, it is a lot of money. So they would like to do a benchmarking first. They see how the end result is, and then only they do the investment. So that's the reason we have this QVCs with all these machines, high-end machines in our facility to facilitate our customers.
Correct.
I imagine with the semiconductor industry picking up pace in this part of the world, I imagine that a lot more interest will be generated in these solutions. My question to you is that, are you seeing interest? I mean, large conglomerates, large companies are investing into semiconductor in different parts of the country. Do you see interest from their sides into these technologies, particularly the 3D X-ray solution? Because I believe it has a lot of application in that area as well.
Yes.
Yeah. See, semiconductors, still we are yet to see movement on the ground. We have other devices similar in the same space as Hemanth was explaining. We have X-ray microscopy solutions which are more pertinent for the semiconductor industry. We have seen requests coming from them for discussions, but ground level activities yet to kick off. Right.
Hemanth, yes.
It's a very initial stage as far as electronics is concerned, but anyway, we has moved on a little more than electronics, where we have seen that such technologies already people have embraced the technology and they have taken the solution in their labs, and like that, electronics also will grow in the coming days, and these products will definitely be used by them in their quality control labs as well as in the production shop.
For the interest of time, let me move on.
Yeah.
So, as was explained in the videos, you can see that the one on the left is a safety belt latching mechanism used in the car. So it's made of plastic because lightweighting on low cost. So, but you have to look at you have to be careful to look at the pores and porosity and how the shrinkage happens and so on. Hemanth, other comments on the other topics?
Yeah, basically, again, like all the measurement dimension, you also have a tolerance band. For porosity, also you have a tolerance band. So the blue color, it represents the certain size of the defect, and the red ones are defects which are out of tolerance. So that's how the representation of component with porosity will be explained to the customer, and this the same report goes to their OEM. And on the right side, you see the overall superimposition of the CAD model over the measured virtual image. And here you see how much is of the metal is poured here, which is it is exactly representing the perfect CAD model, or is there any deviation? The blue ones are the places where there is less material. The red ones are the places where there is more material. Also, the shrinkage and warpage analysis can be done with this tool. And on the last part, you see some inclusions, flashes, burns. Mostly, it can be done in both 2D as well as in 3D way. And all the software tools are available with us to do the complete analysis on the X-ray machine.
So this is, as we were mentioning, Anand, about shortening the manufacturing process. So from the requirement in research, you move to product and process development and production of the item. Then you have an initial test sample report. Then you go into the serial production once a customer approves. So, your question was very pertinent, Anand. So as you can see, computer tomography can be used to evaluate whether all the components fit together and are assembled in a non-destructive way. You can measure and see if things are right in a non-destructive way. So this is where, how we could support even a bottle and a cap manufacturing industry to see if it fits in, because it is made in huge volumes and the timing is important, whether it is a new shape design or a summer is approaching and you have to put in millions of bottles in the market. So timing is quite important in these industries, and the CT technology can really fasten your development of dies and molds.
Yeah, it completes the complete process chain. You can fit the machine where you want, and we have solution for the complete process chain, right from the research to the serial production and assembly.
Right. Another example of die and mold for a connector, for a complex, what do you call, looks like a MCB connector on the left and tool and die on the right, the plastic on the right. So similar applications are possible.
Yeah.
So from the initial sample test report, you are able to go faster, give a faster feedback. Right. Okay, this is just for the viewers to see how Kinder Joy, a common toy, a common candy, what you buy for your kids. So this has been CT'd, and you can see the various parts of it. The edible part, the plastic toy, which is inside the Kinder Joy, and also the separator and the tool to eat the candy. So
right. Basically, what we represent here is the chocolate has got different density of parts. You have a very soft material, the chocolate. You have a plastic. You have a paper inside. So everything can be scanned, and the representation is in different gray levels. The advantage is, even if you have multi-material, you'll be able to scan it, and then you can do a segregation. Now you see only the toy which is visible because of different density. Then you see the spoon, then the chocolate. So this kind of segmentation of the assemblies can be done in a very easy fashion, and this gives a lot of visibility for the designer and for the manufacturer.
Right. So moving on, applications can be for consumer electronics. You can see on the left side is a damaged battery, which is having the anode cathode, which has been impinged into. That could be seen without destroying the battery. Dashboard electronics, if there is a failure, could be easily retrieved as a whole assembly, inspected to see if there is a disconnection of a wire, or even rat shit or whatever. These topics can be seen. And connectors are very complex, looks very simple as we use them, but please imagine that every connector has at least about 300 to 350 dimensions, and it takes a hell of a lot of time to qualify them. And CT provides a very quick solution to qualify these connectors.
There are two pictures on the right side. Just go back, Manoj. The challenge is what I like to say is you have a metal insert on a plastic. The left side, you can see the metal pins are not clear, which means the edge definition is not good. So we have certain software tool wherein we correct these edges with a special tool, software tool, and on the right side you see a clear image. So these are the challenges which the industries will face. But we do have a right solution to offer to customer wherein you'll be able to visualize the products or the part which is very good for the measurement aspect. Next slide.
So this is again coming back to the EV. You see the motor on the left top, and the motor has the copper hairpins which are getting welded. What you see on the second image is the welding, and there is one welding in the middle which has a huge porosity, black color porosity, what you can see. So when there is porosity, there is less current flow because there is a higher resistance because the two metal bodies have not welded together. So if there is a current flow, then that means more heat is generated, loss is there. So this can be visualized in the bottom. You can see all the weld areas can be seen separately in a CT. Thereby you can qualify if it is if the tolerances of porosity are being met or not, and what is the volume, what is the void level, what is the size of the void, and what is the morphology, whether it is oval, what is the shape of the void, and the volume inside the void can be calculated. On the right, what you see is the battery, and the layer below, the black and white gray area, is basically the anode cathode layers. So you could look for defects and to visualize, and the battery engineer would be able to see things what normally he would not have seen once it is assembled. Moving on, I think we covered this, the bottle cap example. And also wall thickness is another common area. Again, comes to the point of using less material concerning an environmental topic. So the thickness have to be reduced to a point where it functions, but it does not, it does not fail. So you want to look at wall thickness in the hidden areas, under the area where you are latching, under the latching mechanisms. So that can be visualized very nicely. Anything from your side, Hemanth?
Actually, the current process takes a lot of time. You have to really, if you have to check the wall thickness across different sections, the current process takes a lot of time. But here in a CT, the advantage is once you have the scan, you go to a particular area, click a button, then you have the details, entire details in few seconds. So that's the speed at which the computer tomography works.
Yeah. Okay, so summary slide. Hemanth, you can mention.
Yeah. So in summary, I would like to tell you that we can measure part from 1 millimeter to close to a meter. The resolution of such system is about starts from 3 microns and to 300, 400 microns is the resolution of Metrotome systems. And depending on the type of the component, depending on the intricacies, we can scan the part in a minute, or it can go up to 10 hours as well. So these are the few possibilities. We can do metrology, or we just do a basic analysis. It's also possible, or just a visualization. It's possible. And everything what we measure, it has got an accuracy component into it, because the standards are specified in Metrotome as per ISO standard. So whatever you measure, it has got a traceability. So this is what now the Metrotomes are used in the industries, and we have quite a good of installation in India and across the globe. And this technology is the future, and we see a lot of potential in the coming days in all the sectors what we are discussing now, on the EV, additive, medical, electronics, and even the plastic or the toy industries. So this is the use of Metrotome to the complete industry as of now.
Good. So summary slide, as you can see here, 10 points, if not more. First is save money. I would put that as the first point to the industry. Second is make the invisible visible. Don't have to cut parts. Get a deep understanding of what goes on inside your components. Reconstruct your parts quickly in a simulated way. Complex, you don't need any fixturing for Metrotome. So just put the part inside a Metrotome and you can start the measurement and get full insights, if not within seconds, at least within a day. So, I mean, that's what I would say is an advantage. So the technology, if not make in India, it is available in India. So please make use of it. Talk to us. Now we will move on to, we maybe have another 5-10 minutes, so we'll move on to the another topic, which is something related to the battery topic. As you see here, there is a new energy vehicle where you don't have, you have a battery tray at the bottom. You have electric motors, transmission, car body and power electronics. One thing is we are able to measure everything around it, starting with power electronics to the transmission. We could measure any topic here concerning dimensions. If you break it open, you can see that the battery tray is at the bottom of the vehicle, generally covering the length between the wheels, and it would probably contain about 3,500 to 4,500 individual cells if it is a cylindrical cell, or could be about 80 to 100 long pouch cells. Depends on which kind of technology the manufacturer is using. But the requirements of the battery tray remain similar. So if you look at the process in which a battery tray is made, there is a welding process by which the tray is formed. Then you need to be reasonably accurate so you do a milling and drilling of the different holes and different locators. Then you move on to full field inspection, because during the welding things would have warped and you would like to see if the warping has happened during which stage. Coming to critical functions control, probably a question can come into the mind of people that battery tray is just a tray, right? Like a coffee tray. Probably, but actually I can see Hemanth laughing. Actually, this battery tray is quite a complex item, because the energy which is dissipated in the batteries, they are the most important factor for safety. Dissipation of energy which is generated during the charging and the discharging cycle of the cells. So the tray has to have a cooling system, a cooling mechanism. So you will, it is almost like a radiator. It is a combination of a battery tray and a radiator to take the heat away and be very rugged in the event of a crash. And it serves multiple functions. It has to keep the batteries really safe and also dissipate the heat out. So there are many factors involved in a battery tray, and hence the base item of the battery tray gets into a lot of measurements, including measurements in the X-ray, which is the structural analysis of the weld joints are made in a CT. Any comments from you, Hemanth?
No, go on. I mean, I think we are running short of time, so
yeah. So this is a short video. In this case, it's a prototype battery tray, which is getting measured on another technology called GOM 3D structured light measurement method, by which we can measure the tray, collect the information, and then give you information regarding the dimensional integrity and the warping topics. Let me move on. Coming to the car again, if you look at a car in future, in about 7 to 10 years from now, when you buy the next car, you'll be paying more for the electronics, the PCBs, the control units, ADAS systems, and so on. So there are a lot of topics around these cameras and electronics which is used, like failure analysis, visual inspection, optical measurement, and so on. So let's look at some solutions which are being offered using microscopy in these areas. You see the center is a car. There are sheet metals used in various areas. Lightweighting is happening. Aluminum sheet paintable bodies are used. A lot of plastics will be used, formed plastic, which should have which should reduce the NVH quotient of a EV vehicle. As you all know, IC engine was very good in generating a lot of noise, so we didn't bother much about the noise from the other parts. But as the IC engine doesn't exist, the motor is a very silent mechanism, so you have to be careful about forming the plastics, aluminum and sheet metals in a nice way that they don't start rattling in few years. This is going to be a key topic for the EV car maker. So these are the areas where we are involved. Some examples are shown here, starting with using microscopes for finding out the inclusions in the steel, what is used in the car. Looking at the welded seams, there are a lot of welds around the car body, and these welded seams can be inspected using optical measurements to look at the quality of the weld. Coatings, a lot of coatings to make the car look good. So the thickness, surface structure of coatings, the kind of surface finish, which will give a nice reflection to the high-end car. There is a surface finish quotient involved here. So that can be measured. Extruded parts like wipers also carry a very nice definition of the contact area. So this can be seen using digital microscopes. Moving on to the interior of the car, what you look for is a surface feel. The kid would sit in the car and say, no, I don't like this car. So there is an internal feel, touch and feel of the upholstery, touch and feel of the dashboards. They can be measured and quantified using our equipments. Including a very key safety topic is when you have an airbag, you have micro weldings done around the airbag locations, and they have to work. So you must inspect these laser shot weldings to see that they are having the right structure so that they will get released in the event of a crash. Display issues and defects on plastic components can be seen. Again, in the internal for IC engine, so let's all be also clear that IC engine is going to stay for at least about 1.5 to 2 decades. Let's not bid adieu to it. And there are topics around component cleanliness, oxygen sensors, spark plug, issues in ceramics, and so on. So this is one area of our involvement, our solution space, which is not very well known, the microscopy topics. So we would like our customers to get back to us. A kind of product line, if we have to show, we showed you the CT product line. This is the microscopy product line, starting with stereo, digital microscopes, compound microscopes, and confocal systems. So they work at varied resolutions. If you talk about stereo, it works at about 1 to 5 microns. Digital works at about 0.6 microns. Compound microscopes in the same area, and 1 nanometer could be achieved using a confocal technique. Still further, this is not good enough if you talk about failure analysis in the industry. So we have X-ray microscopes and electron microscopes where you can do a lot of material and failure analysis in the nanometric scale. Again, these equipments are available at our offices in Bangalore. We would like the industry to take advantage of it. Come, walk in and do a pay-per-use service. With this, almost we are at the end of the spectrum. This is one last page, which I would like to share. We talk about products, applications, market segments, different departments in the company, and finally our customers. So our customers are into, starting from the right, our customers are into the R&D units of the company, quality labs, metrology labs, incoming inspection, and production. And the market segments could be in automotive, aerospace, manufacturing, electronics, medical, and windmill. Just to give you a link, if you have a digital microscope, you want to inspect PCBs, It could be the production guy who wants to do, we have a solution. If you want to look at something as a failed part has come back into the company, you want to inspect the electronics failures, then it could be the R&D guy who's doing this, and we have a solution space for it. Again, our solutions have a idea of there are different softwares to do the same job. If you want to look at the failure analysis in deep detail, then we have a different equipment for it. If you want to look at the technical cleanliness in your process in the automotive IC engine, we have a solution space. So just want to say that we are industry agnostic, so we could provide solutions to a variety of industries. I think, Hemanth, any last comments from you?
Yeah, I think we have shown the complete product lines from both X-ray and microscopy, wherein there are different applications, different segments. But I would say in all the segments we are there, and we are supporting our customers through our various or different QECs. There are product experts available who provide solutions for their challenges, and that's how we are trying to help our industries to move forward. So I would like to request the listeners that if you have any such challenges, be it measurement or the analysis topic, please approach us, and we are there to support.
Right. Yes.
Yeah. So, Mr. Anand or listeners, if they have any questions, I think we are there to answer.
Absolutely. Thank you so much, Manoj and Hemanth, for that very, very informative presentation. I was like a child in a toy store, and I'm sure that's how our viewers also feel, because we do hear a lot about Zeiss and its technologies and innovations and inventions over the years. But this is the first time we got a deep dive into the many solutions that your company has been providing us with in the machine, whether, and your company reaches out to us, touches at us in so many ways, from diagnostics, from medical to the movies. So it's quite an experience. This the time flew past the last 1 hour, and I thank you once again for these insights. I have quite a few questions that we have got from the audience. I have a couple of my own, so I'll combine all of that. So my first question to you, Manoj and Hemanth, is Zeiss's R&D focus. So you shared with me in the beginning that the company spends about 16 to 17% into R&D, and that's quite a big number, which is obviously understandable. But from an industry perspective, to give you an idea, industrial companies spend about, in single digits. Yeah. This is as high as pharma companies and healthcare companies. My question to you is that in recent years, and one thing that is really very talked about is your quality excellence centers, if I'm not mistaken with that term. I hear this a lot in industry circles, professional circles. Zeiss's quality excellence centers are quite well known. I believe you opened one in Michigan in October. You have one in Bangalore. So could you tell us, our viewers, more about your centers, quality centers, what they do, the kind of talent that you engage in these centers, particularly that in India? Manoj?
Hemanth, would you like to go? You're muted.
See, Quality Excellence Center, basically the idea, it started way back, but in India, it's now close to 12 years, if I'm not wrong. Close to 12 years, we have started a small, we call that a tech center earlier. So we started with 1 CMM. And looking at the interest of the customer, because what we understood from the market is, they may have machines, they may have people, but sometimes they lack the right kind of training or right kind of measurement strategy, because they are they're so much engrossed in the day-to-day activity, they do not have time to explore the other possibilities. So that's the reason we have started our tech center. And when people come here for training or for finding a measurement solution for their problems, it is not only one mind which is discussing the issue, there are multiple minds, means from the customer side and from our expertise side. And once they come with a problem, they will definitely go back with a solution. So this we could experience, from day one. And we found that this is a very, very important aspect for the customer and to be closer to the customer. And this created the thought process in our management, and they decided to have the tech centers in different multiple locations here in India as well as abroad. And not only CMMs, now we have spread our wings, we have brought in multiple technologies. And the idea is to have every single product segment, we should have one product line in our tech center, so that the customer whomsoever walks in, they don't come with one measurement aspect. If they come inside, they get to see a complete gamut of products what we have and the kind of solution what they can take from our QAC. So that's how it is becoming more and more popular here in India as well as abroad. And this is the time wherein we are getting into different segments, be it electronics, be it NEVs. We are getting into different segments, and now customers are finding it extremely useful to come to our tech center, take the measurement services, take the training, and then go back with the proper training and knowledge level. So this is how we are helping our customers, and they are getting benefited. Manoj, from
I would just say that, make in India doesn't mean only making in India, but also supporting in India. That's how we can enable, make in India to go faster to the end point. So these investments, what we have done is not, if you really quantify it as a number, the kind of equipments what we have in our Bangalore office would simply total up to about 15 to 20 crores of equipments which are available for anybody who walks in. And particularly, we want to look at the SMEs, what you mentioned. So when somebody is doing in a startup mode, he may not have the luxury to invest in all these equipments. But today, if you want to put your product to the world, you definitely need these equipments. So how do you tie up these two ends? So that's where these QACs come in, that he can use it. He can use the latest technology with, as Hemanth was mentioning, the skill level. So you may buy a equipment. If I give you a gun, will you be able to shoot it very well in the day one, day two? No, you need training and you need skill. So it is not enough if you have the equipments, you need skill and skilled manpower. So we have both. We have the technology, we have the backup from our corporates, guys sitting, and the knowledge pool, and we train our people. So this combination is really beneficial for the SMEs. And that's what they are really lapping it up. As we said, that our equipments are always busy. Yes, if you look from a business point of view, there could be a thought that, are we delaying the revenue? Yeah, it could be, but I think we are doing the right thing by sowing a seed in the minds of the people to use the right equipment. And we know that in our experience, it has daily benefited us both ways.
You said something. Yes, please, Hemanth.
Yeah, from the R&D perspective, you said the kind of investment what you're doing. Just to add one perspective to that, the revenue which we make, the yearly revenue which we get, more than 50% of the revenue comes from the product which is just 3 or maximum 4 years old. Which means the product which is, because it's an innovation company, we spend a lot of money, we innovate a lot of products, and more than half of the revenue comes from a product which is just 3 years old in the company.
You said something very interesting during our earlier session, was that SMEs could approach their associations,
Yeah.
for solutions that are beyond their reach and affordability. Now, my question to you, both of you, is uh, do you have any such ongoing association engagements with industry associations? And if yes, or is there some kind of an interest that industry associations have raised with you? Is there some kind of a synergy? And if so, could you give us like a couple of examples, particularly from the machine tools industry, from where we have a lot of viewers, and the smartphone industry, if possible?
Yeah, I think on the machine tool and the auto component industry, we have had quite a few industrial associations in Maharashtra, in Bangalore, Bangalore, and one in Pune. They have approached us. They have taken our base solutions for setting up their laboratories. So this is ongoing in the automotive industry to quite a good level. In fact, recently we had the Tamil Nadu government and Boeing. I think they are collaborating to set up some advanced manufacturing setups, and we are also working with them by delivering our tools. As far as the semiconductor and electronics industry is concerned, they are still probably the processes is all very closed. They have their own USPs and own recipes which they don't like to share. So it's still not a very open industry at the moment. So it might take some more time for them to come to this level. What I mentioned is what tools, for example, one more initiative from the central government is setting up a national additive center in Hyderabad, in Hyderabad, yeah. And they are trying to set up a pool of equipments and pool of manufacturing setups where people can do prototyping and they can do the measurement. So the government is also taking a lot of initiative in this regard. So,
the next question is about, sorry, Hemanth, you were saying something? Okay.
No.
Okay. So the next question is on EV, and this is about battery safety. Now, as you know, the government has issued some new battery safety norms very recently that has almost brought some production, some new startup productions to a halt, because they have to really comply with it very in a short span of time. Now, the question is about battery safety, how Zeiss can help startups and companies ensure that their batteries comply, and their battery management systems overall comply with the newer and more stringent norms, not only in India, but also for the overseas markets.
Right. Okay, the AI 156 norms, which have been released recently, they, as you rightly put it, they pertain to the topic around battery. When we say battery in the terminology, it is a collection of cells and the BMS. So, in India, we have very little battery cell manufacturing, but more battery pack manufacturing people. So this AS 156 standards are mostly for the battery pack makers, so that they adhere to quality standards in, as we mentioned, about the thermal runaway issues, which caused a lot of problems in the months of April, May, June, during the summer months. So they have put in a lot of norms around the battery pack, for which we do have some solutions, maybe not too many, but battery pack guys can come in, use the X-ray CT machines for looking at the integrity of the battery pack. Let's say after 200 hours of road usage, how the welding joints are, whether the BMS is in correct shape, and so on. So that is one area where we can support them. Where we have a deeper reach is when they are buying the cells. When you are buying quality cells, are you sure you're buying the right cell which was promised to you at the time of purchase? Is the cell internal structure of anode, cathode, the micro weldings, the separators, are they in correct shape? And you can qualify them by dimensions, by chemistry. So this is the area on the cell topic we have a wide array of solutions. So these is the two areas where we can help the community. And many startups are taking support from us, particularly in Bangalore. There are quite a few EV startups which are taking support from our space QVCs.
That's great to know. Now I'll conclude this discussion with a question straight from the audience. I'll just read it out. It's a very nice question. Okay. How can Zeiss help Indian government or states in making this important machines for healthcare in medical technology become available in tier 2, tier 3 cities, even in remote districts? Because cancer treatment is very expensive, and with only few centers, people have to come to cities like Mumbai, Delhi, and Bangalore for such facilities. Over to you.
So this is a question for our other division, which is the medical division. So we will not be able to answer this question. This is about doctors and hospitals and solutions. So.
Absolutely. To my viewers, to our magazine's viewers and Zeiss's consumers, Manoj and Hemanth are there. The company is there for you to reach out to them through various platforms, including ours. For any such questions, please reach out directly. I'll also forward this question to Manoj and Hemanth to take to their respective departments to answer this question. I hope our viewers really enjoyed it as much as I did, and we will welcome all the questions that you have for our forum. It has been an excellent presentation and a session, Manoj and Hemanth, and thank you so much for these deep insights into your business and technology.
Thank you, Anand.
Thank you so much.
Thank you.
Thank you.
Thanks for
Have a great day.
Have a great day.
Thank you. You too. Bye bye.
Bye bye.